All right, question number 11. It wants us to find the domain, any asymptotes, x-intercept, y-intercept, and graph the function. We're going to do all of this by hand, and then we're going to check with the graphing calculator once we finish. So let's start with our function f of x equals 3x plus 2 divided by x. Okay, so we're going to start with our vertical asymptote, what makes the denominator equal to 0, and that would just be x equals 0. Okay, we don't have anything to solve. If you set it equal to 0, you just get x equals 0. So we have our vertical asymptote. We're going to try to find horizontal asymptote if there's any. Okay, so horizontal asymptote, you compare the degree. So I have a single x and a single x, so it's the same degree. My horizontal asymptote would then be the ratio, so 3 over 1, which is just 3. So we get y equals 3. And given that we have a horizontal, we will not have an oblique. So these are our two asymptotes. Now I'm going to go ahead and start the graphing process. We still got to find intercepts. So x equals 0 would just be this line. This is x equals 0. So it would be like a dotted line here that the graph would not cross. And then y equals 3. 1, 2, 3. So there would be a horizontal dotted line across y equals 3. We now want to find the x and y intercept. So y-intercept, we're going to plug a 0 for x. So if we do y equals, and we'll have a 3 times 0 plus 2, and then 0 on the bottom. So no matter what happened, we'll end up with 2 over 0. That's undefined. So we will not have a y-intercept. We'll say none, does not exist. As far as x-intercept, we would plug in a 0 for y and then solve for x. So I would multiply by x on both sides. So x times 0 would be 0. Multiply by x here, we'll get rid of that. So we have 0 equals 3x plus 2. 3x plus 2. Subtract 2 and divide by 3, so we get a negative 2 over 3 equals x. So our x-intercept, we will go, here's a negative 1, so negative 2 over 3, so somewhere in between 0 and 1, like 2/3 of the way right here. This will be our x-intercept. Now, based on these equations, these are both linear. So I know linear equation is going to be a straight line, positive slope, or a negative line going down for negative slope. So you can kind of use approximation and predict how the graph will look based on the end behavior. So I know as this graph goes to the right, it's going to be going to positive infinity, or in the upper right corner, and on the left side it would be down in the left corner. If it was a negative, it would be the opposite. So we have options. We have a section here to here, negative, and then here to here, positive. So since this is positive, I would believe we would be in this would be like the upper first quadrant and maybe the third quadrant down here. And so it's usually always this kind of like curved line. Looks like that's where the x-axis is going to be, or the x-intercept. And then kind of like a mirror image up here. So that would just be my rough estimate, and we can plot points to see. But we have our asymptotes, we have our x-intercept, which would be negative 2 over 3 comma 0. We don't have a y-intercept because it was undefined, and then this is what we think the graph would look like. So let's also graph it. It's clear. I don't know what scale they will have, but we'll at least graph it. So I'm gonna do alpha y equal enter just to make the fraction bar. Then avoid avoids me having to use the extra parentheses. 3x plus 2 over x. And if I graph that, so I'm going to go zoom 6 to get the standard graphing window. Okay, so it looks similar. This looks like we're on the right track. We can probably see that that's a little bit above that axis. All right, so let's plug in our other values. So our domain did not use 0, same as my vertical asymptote. So if we were to remove 0, we would get B. The x-intercept, we said type as an ordered pair. So that would be -2 over 3, 0. Y-intercept, there was none. And then it wants us to choose the correct graph. So I'm looking for between D and B looks more correct. Let's try to figure out which one. So if I'm counting the tick marks, this is 1, 2, 3, 4, 5. So this looks like 2, 4. So we said our horizontal asymptote was 3. So that looks like to be right there in the middle. That one looks good. Let's compare B. You can see that this vertical asymptote should be 0 on the line y equals 0, which is, sorry, the line x equals 0, which is right here on the y-axis, and that is off. This is 1, 2, 3, 4. So it looks like these are counted by 5, 10, 15, 20. Nope, 4. 4, 8, 12, 16, 20. So the y equals 3 looks about right, but the vertical asymptote x equals 0 is not. So because of that, we can conclude that D will be our correct graph.